Hello everyone. Today continue to discuss about the image formed by lenses. Let's start by what we call converging lens and then look how image is formed. So by this this will help us to see clearly what is the image, what is the object. So let's try to identify or to look here. Of course, this is the object position, and this is the focal point, whereas this is convex lens. Also, we have the image which is real. For this case, we are observing now here, the image is beyond, so it is between focal length and 2f, whereas the object is positioned beyond 2f. So we are going to see different positions of the object and the image which can be formed by using this convex lens. So normally let's identify these rays that can help us to form images. Normally, as we know, we have three rays that can help us to form image. The first one is there is a ray which is parallel to the principal axis. A principal axis, it is this horizontal line passing through the lens, this dotted line. So a ray parallel to this principal axis will reflect by passing the focal point. Also, a ray passing through the center of the lens will continue to move without deviation. Also, the third ray should pass through the focal point will reflect parallel to the principal axis, this one. So let's try to analyze to see a different position of object by using this convex lens, and then look how image look like. So here, as we see, the object is beyond this 2f, so that the image is positioned between 2f and f. So what can happen if image is in 2f? When image is located in 2f, so as we see, the image is the image distance, this one, and the object distance is the same as the same. When object is at 2f, the size of the object are the same, even the size of image are the same. What can happen if object is located between focal length and 2f? As we see, the image is magnified, and also the object, when it is between f and 2f, and the image should be real because it is inverted and beyond 2f. So let's use an arrow in order to specify directly, so that we look how we can measure the object distance. Now, by using the meta rule, let's measure the object distance. Object distance is 160 centimeters. This is the object distance. 160 centimeter. It is the object distance. Let's look at the image distance. The image distance is 140 centimeter. So you see, the object distance is smaller than the image distance here. So the image here is smaller than the object height or size. You can measure the height of image, even the height of the object. They are not the same. They are not the same. Let's try continue to locate this image object. Sorry, the object is between f and to f. As we see, the image is now increasing. In to f, when we are beyond to f, the image is too small. As we move closer to f, the image are the same as object. As we continue to move, let's put the object between f and to f. You see, the image is inverted and greater. So, what can happen if we continue to move, to change the focal length, sorry, the object distance toward the focal length? The size is now increasing of image. When you put into f, when object is located at the focal point, the image always is focused at infinity. Always parallel lines are moving to the infinity. Let's look how is the case when object distance is in between the lens and the lens. When the object is between focal length and the lens, which is convex lens, here the image, as we see, is upright, means virtual image. When the image is upright in the same position as object, here the image should be real. So it is a virtual image. It is the image which is located at the same position as object and always is upright. This is what we call virtual image. So this is how a convex lens forms image. It is a virtual practice that can help us to see clearly how image is formed by this convex lens. Lastly, we can end our session by looking how an image can be formed when focal length increases or decreases. Let's change the focal length. When the focal length decreases, let's change the focal length and see what will happen to the image. Let's try to decrease the focal length. When you decrease the focal length, as we see, the image becomes too small. It means the lens power is increasing. This can show us when the focal length increases, the power of a lens decreases, because as the focal length increases, also the power of the lens changes. They are inversely proportional one to each other. When the focal length increases, the power will decrease. When the focal length decreases like this, the ray is automatically converged. So let's summarize by today's session. I hope this simulation will help us to understand clearly how convex lenses are able to form image. Next time we shall see how image formed by convex lens is. Thank you so much. Let's meet next time, and I hope everyone is able to see the image formed and to analyze the image formed by the convex lens.